Hello friends, I am Dr. Himani Garg, working as professor in Department of EC in AKGEC Engineering College, and today I am going to discuss about channel assignment and interference in cellular system. As you are aware, cellular system in wireless communication means we are dividing the area into cells so that we can use the concept of frequency reuse and we can have more number of users in a particular area. Now, what is channel assignment? In heavy traffic conditions, all active subscriber in a cell may use up all the channels and there may be demand for extra channels. So as we are saying, for a particular cell, number of channels will be there, and if all the channels have been used, then the other persons will not be able to use that particular channel. So we will have to assign some channel assignment strategy so that more number of users can use a channel. The aim of channel assignment is to efficiently use the available radio spectrum and to provide best possible services so that a subscriber doesn't lose any call due to unavailability of channel. So this is the reason that we are discussing about channel assignment. Now the various strategies for channel assignment include: first is fixed channel assignment. As the name suggests, fixed channel assignment means if you are having 7 cells in a particular cluster, then all cells will be assigned fixed number of channels. In the fixed channel assignment, each cell is allocated a predetermined set of voice channels. We are talking about voice channels, not about control channels. Only the unused channels in a particular cell can serve any call attempt within that cell. So, whatever number of channels have been assigned, the number of users can use that particular number of channels. If all the channels are occupied, for example, if 10 channels have been assigned to a cell and all the channels have been used, then the call will be blocked and the subscriber will not get any service. So this is also one of the disadvantage of fixed channel assignment. Now, the another strategy is borrowing strategy. Borrowing means you can borrow a particular channel. In the borrowing strategy method, a cell is allowed to borrow a channel from a neighboring cell. So if number of cells are there, if any channel is having a particular number of channels and that channels have been used, all of the channels have been used, then he can borrow channels from the neighboring cell. The MSC supervises the borrowing procedure. So the borrowing is taken care by mobile switching center. This is taken care by mobile switching center. It ensures that the borrowing of the channel does not disrupt or interfere with any kind of calls in progress in the donor cell. So, if you are accepting something from a neighbor, then it has to be taken care by the MSC that the donor cell, there is no interference in the calls of donor cell. So, this is taken care by MSC. So, supervision is done by MSC. So, this is better than fixed channel assignment because here we are having an option of borrowing. Now, the third one, that is dynamic channel assignment. So, that is totally different from fixed. In the fixed, we have the fixed number of channels, but in the dynamic channel assignment method, voice channels are not allocated permanently in any of the cell, not fixed. When a call request is made, the serving base station requests a channel from MSC. Here also, the main supervisor is MSC. So, whenever we have to make a call, then this request goes to MSC, which then allocates a channel to the requested cell, Now, the advantage is that the likelihood of call blocking reduces because if we are having the dynamic cell assignment, it do not depend upon the density of people in a particular cell. In a particular cell, if in a particular cell the channel assignment is dynamic, then whatever the number of users are there, they can get the channels from the MSC. Co-channel interference reduces and the channel utilization increases. So, these are the advantages of dynamic channel assignment. Now, as we are saying that these all things are taken care by MSC, so MSC should be active enough to see all the things that which user is wanting, which cell is demanding for a particular channel, and he has to provide that channel to other user also for the frequency reuse concept. So, he should be active enough to take these decisions. So, this is also comes under the disadvantage of this dynamic channel assignment. Disadvantage is that MSC must be fast and capable of collecting real-time data on channel occupancy, traffic distribution, and radio signal strength, indications of all channels on a continuous basis. So MSc should be active enough to see that which channels have to be provided to the different users. Now, after the channels have been assigned to different users, different cells have been assigned the channels have been assigned to cells, there comes the problem of interference. Interference is a term that is we generally see that any unwanted signal comes to the unwanted signal, then it called interference. Now, the sources of interference in the case of cellular system can be another mobile in the same cell, a call in progress in a neighboring cell that can also cause interference, other base stations operating on the same frequency band. Another base station is also, I am working on a particular frequency and another base station is also working on the same frequency. It will cause interference. Any non-cellular system which inadvertently leaks energy into the cellular frequency band. So, any non-cellular system can also generate a particular frequency that comes inside the band of cellular system, that will also cause interference. Now, what will be the consequences of these interference in the case of cellular system? First is on voice channel. We have here two consequences have been described, one for voice channel, another for control channel. On voice channel, there can be crosstalk where the subscriber hear interference in the background due to an undesired transmission. So, for voice channel, the interference will lead to crosstalk or there may be some voice at the back end. On control channel, interference leads to missed and block calls due to errors in the digital signaling. As the control channel controls all the communication in the case of cellular system, if there is some interference in the case of control channel, it can lead to missed and block calls due to errors in digital signaling. Now, when we have to discuss about the different types of interference in cellular system. There are two types of interference in cellular system. One is co-channel interference, another is adjacent channel interference. We will discuss about these two interference. Now, what we mean by co-channel interference? Frequency reuse implies that in a given coverage area, there are several cells that use the same set of frequencies. As we know that in cellular system, the concept of frequency reuse is used. That means the same frequencies are being used by different users. If one is working on F1 frequency, then some other user that is at a particular distance from that user is also working on the same frequency F1. These cells are called co-channel cells. So, the cells that are using the same frequency, they are called co-channel cells, and the interference between signals from these cells is called co-channel interference. So, the terminology must be clear to you that co-channel means the channels that are using the same frequency, they are called co-channels, and the interference due to them is called co-channel interference. Now, one of the way to decrease the interference is to increase the signal power. Whatever we are, as we know that signal to noise ratio is the ratio of signal by noise. If you increase the power of signal, then obviously the noise factor can be reduced. But in the case of cellular system, if you increase the signal of the transmitting signal, if you increase the power of the transmitting signal, then there will be more interference with other channels that are using the same frequency. So, we can't remove the interference with by increasing the signal power. Unlike thermal noise, which can be overcome by increasing the SNR, co-channel interference can't be combated by simply increasing the carrier power of a transmitter, because an increase in the carrier transmit power increases the interference to the neighboring co-channel cells. So, this is not the solution so as to decrease the noise. Now, what are the various ways by which we can decrease the co-channel interference? We will discuss about this. To reduce co-channel interference, co-channel cells must be physically separated by a minimum distance to provide sufficient isolation due to propagation. So the best way to avoid co-channel interference or to decrease the value of co-channel interference is to keep the cells that are using the same frequency at a sufficient distance so that they do not cause any interference. For this, we will discuss about the different parameters like R, radius of the cell, D, that is the distance between center of the nearest co-channel cells. Now you can see in this diagram, if this is a center cell that is using a particular, named as A, he is using a particular frequency, and another cell, this is also denoted as A, he is also using the same frequency, this is also using the same frequency. They are co-channel cells, these are all co-channel cells. They should be at particular distance, sufficient distance from each other so that they do not cause co-channel interference. So this is a way we can reduce the co-channel interference by keeping a certain distance between both the co-channel cells. Therefore, by increasing the ratio D by R, D means distance between centers of the nearest co-channel cells, the spatial separation between co-channel cells relative to the coverage distance of a cell is increased, thus interference is reduced. So the simple thing is, two cells using the same frequency, they should be at sufficient distance from each other so that there is no co-channel interference. Now, we will discuss about the relationship between co-channel reuse ratio and cluster size. This is one cluster, these 7 cells form one cluster, these 7 cell blue cells, they form another cluster. Now, this number 4 and here also the number 4 denotes that these both cells are using the same frequency. So the distance between their centers is denoted as D and R is the radius of a particular cell. Now we are saying that Q, that is co-channel reuse ratio, denoting the co-channel reuse ratio is denoted by D by R, is the ratio of D by R, that is the distance upon radius, and it is dependent upon cluster size also, and it is given by under the root of 3n, where n is the cells per cluster. So we have to check this parameter Q, that is the co-channel reuse ratio. Now we can see here co-channel reuse ratio Q, that is the same formula here. Now according to the cluster size 7, this is the cluster size 7 or 3, cluster size 3 or 7, there is a value of Q, you can see here 3, 4.58, 6. So as you keep on increasing the cluster size, the co-channel reuse ratio increases. From this table, you can derive that a small value of Q provides large capacity. Small value of Q provides large capacity since the cluster size n is small. As the cluster size n is small, so more number of clusters will be required to cover a particular area, and capacity depends upon the number of replication of a particular cluster if is directly proportional to that. So if the number of times we are replicating a particular cluster in a particular area increases, then the channel capacity increases. So that's why it is written that small value of Q provides large capacity as the cluster size n is small. A large value of Q improves the large value of Q. What we mean by large value of Q? Large value, if Q is large, that means D is large. D is large means the distance between co-channel cells is large. As the distance between co-channel cells is large, that means the co-channel interference will be less, because we are keeping two cells who are using the same frequency at a certain distance, at a large distance, so the co-channel interference will be less. So we are having two things. One is we can keep the value of Q as small for increasing the capacity, or we can take the value of Q as large so as to decrease the co-channel interference. Therefore, a trade-off must be made between these two objectives in cellular system. So when the cellular design is to be done, so this thing has to be taken care that we shouldn't, if we should keep on increasing the capacity. If you will keep on increasing the capacity, then what will happen? Then the co-channel interference will increase. But if you will decrease on if you will have large value of Q, then what will the system capacity will decrease. So trade-off should be there between the two. Now we will do some calculations for co-channel interference. Now the co-channel cells surrounding a particular cell exist in a circular or rather hexagonal pattern. This is the first cell A. All co-channel cells, they are existing in a cellular pattern, circular pattern. You can see circular pattern. There will be a maximum interference from the nearest cell of the circle of the cells, which are also called first tier cells and are always 6 in number. You can see here, this one is the first tier of the cells that are causing interference. This is the second tier that is causing interference, and then the third tier. So there are different tiers of cells that are causing interference. It is directly visible from this diagram that the cells which are in tier 1, they are causing maximum interference to this particular cell, and the number of these cells are 1, 2, 3, 4, 5, 6. So for this particular central cell, there are 6 cells which are causing interference. 6 in number. Based on that, signal to noise ratio for a mobile receiver, we are familiar with term signal to noise ratio, signal upon interference. Here we are taking the noise as interference. So signal to interference, as here the interference is caused by co-channel cells. So there is a summation of co-channel cells that are 1 to integer, from where starting from 1 to the number of cells that are causing interference. Now II, the cells that are causing interference, there is summation of them, where S is the desired signal power from the desired base station, and II is the interference power of the base station of ith interference co-channel cells. N is the path loss component. The value of N changes from 2 to 5. This is an important parameter, that is the path loss component. So now we will discuss about co-channel interference calculations. Calculations in terms of signal to noise ratio. Here we are considering the noise as interference, and interference caused by different co-channel cells. You can see here the co-channel cells. So now we will be discussing about the calculations of co-channel interference. Here we are that is the signal to noise ratio. Here we are considering the noise as interference caused by co-channel cells. Now as you can see in this diagram, for this particular cell A, the other co-channel cells are 1, 2, 3, 4, 5, 6. So these circular arrangement shows the co-channel cells. So this is the first tier. This is the tier 1 that are nearest to this particular cell. Other cells that are also using the co-channel frequency, they come under tier 2 and tier 3. But we will make the calculation on the basis of tier 1. So the co-channel cells surrounding a particular cell exist in a circular or rather hexagonal pattern. Therefore, there will be a maximum interference from the nearest circle of cells, which are also called first tier cells, as I have shown you, and are always 6 in number. So these 6 cells will be there. Based on that, signal to interference ratio for mobile receiver is given as S by I and signal interference. Now the interference is caused by different co-channel cells. Here we are considering those cells as 6 in number. So you can say that this I will go from 1 to 6, and the interference caused by these 6 cells, that will be added together, and that will give the ratio of signal to noise. And if you describe it in terms of D by R ratio, then signal to interference ratio is given by R raised to power minus N, where N denotes the path loss component. R is the radius of a cell and D is the distance between co-channel cells, where S is the desired signal power from the desired base station. II is the interference power of the base station of the ith interference co-channel cell. N is the path loss component. The empirical value of N ranges from 2 to 5, that depend upon the type of scenario, whether we are talking about rural scenario or urban scenario. The value will change for the path loss component based on the distance of the interfering base stations to the desired mobile receiver. DI, that is D by R ratio, and cluster size, N. So all these things can be related to each other. Now from the last equation you can derive that S is equal to K into R is power minus 1. S is directly proportional to R is power minus N, where K is the proportionality constant which depends on the power radiated by the base station at the center. I represents the power radiated by the other base station in the first star. So I here represents the power radiated by other base station. This is the desired base station and this is the power radiated by the co-channel base station, which are 6 in number. So that's why it is written 6 here. From the above two equations you can write down, you can derive this equation and ultimately we will get this. We are considering 6. Why? Because 6 number of cells. 6 number of cells, 1, 2, 3, 4, 5, 6 are co-channel cells. The interference will be mainly caused by these 6 co-channel cells. Now, if you want to derive this equation in terms of D by R on the basis of distance, you can see here for a 7 cell cluster with a mobile unit at the cell boundary. Here we are having 6 co-channel cells are there and cluster size is 7 and the mobile user is here. Mobile user is here. This is the main base station. Now this channel is getting interference from here, 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 here. Now if you want to calculate the distance of these stations from the center one, you can see the distance between, approximate distance between them is D minus R. Here also it is D minus R. The distance here is D. This is D plus R. This is also D plus R and this is D. So you are having 2 Ds, 2 D minus R's and 2 D plus R. So ultimately in the last equation where we were writing D, here the distance between the co-channels, that can be written as D minus R. 2 co-channels are D minus R distance, 2 co-channels are D plus R at a D plus R distance and 2 channels are at D distance. So this has been given in terms of that particular distance. So this is the equation in terms of distance if we are considering cluster size as cell 7 and the number of cells that are interfering are 6. Now we have already discussed about co-channel interference. Now the next is adjacent channel interference. Now what we mean by this adjacent channel interference, you can see here 2 channels are there, channel 1 and channel 2. They are not working on the same frequency but they are adjacent to each other, they are close to each other. So this is channel 1 and channel 2. You can see this is the desired mobile station that is using a particular frequency and this is the interfering base station, mobile station. You can see this desired mobile station is at 20x distance from the base station, whereas interfering one is at distance x. This is at 20 times the distance from then the interfering station. That's why, so the desired mobile power with the mobile B with low power, this is the desired mobile power and this is the interfering mobile power. So you can see the power, this power shows dotted line indicates when both mobiles are at the same distance, but when this distance interfering channel is at closer distance to the base station and this one channel 1 that is at a longer distance, then there will be interference due to the channel 2 and this will be called adjacent channel interference. And this equation is given by S by I for adjacent channel interference is equal to 20 raised to power minus n, where n is the path loss component. So we have discussed about co-channel interference as well as adjacent channel interference. We have done the calculations for signal to noise ratio for co-channel interference as well as adjacent channel interference. So these are the references. Thank you for watching.